A lightning protection system, or LPS, is designed to protect structures from damage due to lightning strikes. Determining whether a lightning protection system is required involves a risk assessment that considers various factors. Firstly, we will discuss Category 1, buildings, structures, and outdoor assemblies. This category assesses the need for lightning protection based on building characteristics and location. For example, consider a commercial office building in New York City, New York, that is 100 feet tall with 10 stores. Based on this data, a lightning protection system is required. Secondly, let's examine Category 2, which includes open areas, special structures, and miscellaneous equipment. This assessment considers different parameters specific to these types of structures. As an example, let's analyze a wind turbine in Miami, Florida. This wind turbine is 150 feet tall and has isolated conductors or structures nearby, such as power lines. In this scenario, a lightning protection system is not required. Let's delve deeper into the factors considered in a lightning protection system risk assessment. These are 1. Geographical location. The frequency and intensity of lightning strikes vary significantly by region. Areas with higher lightning activity, such as Florida, generally have a greater need for lightning protection systems. 2. Building height and dimensions. Taller structures are more likely to be struck by lightning. The height, width, and length of a building all contribute to its overall risk profile. 3. Type of structure. Different types of structures, such as commercial buildings, residential homes, or industrial facilities, have varying occupancy levels and potential hazards. This means that they require different levels of protection. 4. Occupancy and use. Buildings with high occupancy or critical functions, such as hospitals or data centers, require a higher degree of protection to ensure the safety of occupants and the continuity of operations. 5. Construction materials. The materials used in the construction of a building can affect its vulnerability to lightning strikes. Buildings with highly conductive materials, such as metal, may require additional protection measures. 6. Surrounding environment. The presence of nearby trees, power lines, or other structures can influence the risk of lightning strikes. These factors must be taken into account when assessing the need for a lightning protection system. 7. Isolated conductors or structures. Open areas or special structures with isolated conductors or structures nearby require a different type of assessment for lightning protection. A lightning protection system typically consists of several key components. 1 is air terminals or lightning rods. These are placed on the roof of a building and are designed to intercept lightning strikes. 2 are down conductors. These are heavy gauge wires that carry the lightning current from the air terminals to the grounding system. 3 is a grounding system. This consists of ground rods or plates buried in the earth, which provide a low resistance path for the lightning current to dissipate safely. 4 are bonding conductors. These are used to connect various metal components of a building, such as piping, ductwork, and structural steel, to the grounding system. This helps to minimize the risk of side flashes and electrical surges. 5 is surge protection devices. These devices are installed at electrical service entrances and other critical locations to protect sensitive electronic equipment from voltage spikes caused by lightning strikes. When lightning strikes a building with a lightning protection system, the current is safely conducted to the ground, minimizing the risk of fire, structural damage, and electrical hazards. In addition to protecting buildings, lightning protection systems can also be used to protect open areas, special structures, and miscellaneous equipment. For example, wind turbines are often equipped with lightning protection systems to prevent damage to the blades, generators, and control systems. Similarly, communication towers, power substations, and other critical infrastructure can benefit from lightning protection measures. It is important to note that lightning protection systems should be designed and installed by qualified professionals who are familiar with relevant codes and standards, such as those published by the National Fire Protection Association and Underwriters Laboratories. Regular inspections and maintenance are also essential to ensure that the lightning protection system is functioning properly. Now let's talk about the NEC, or National Electrical Code. The NEC provides guidelines for electrical installations, including lightning protection systems. Article 250 covers grounding and bonding requirements. Article 800 covers communications systems. And Article 780 specifically addresses lightning protection systems. The NEC emphasizes the importance of proper grounding and bonding to minimize the risk of electrical hazards. It also provides specific requirements for the size and installation of grounding conductors, bonding jumpers, and surge protection devices. Here are some key considerations for grounding and bonding. 1. Grounding electrode system. The grounding electrode system should consist of one or more electrodes such as ground rods, ground plates, or metal water pipes that are bonded together to form a low resistance connection to the earth. 2. Grounding conductor. The grounding conductor should be sized appropriately to carry the maximum fault current that is likely to occur. The size of the grounding conductor is typically based on the size of the service entrance conductors. 3. Bonding jumpers. Bonding jumpers are used to connect metal enclosures, raceways, and other non-current carrying metal parts to the grounding system. This helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electric shock. 4. Surge protection devices. Surge protection devices should be installed at the service entrance and at other critical locations to protect sensitive electronic equipment from voltage spikes. Surge protection devices should be properly grounded and bonded to ensure that they function effectively. Proper grounding and bonding are essential for electrical safety and equipment protection. By following the requirements of the NEC and other relevant standards, you can minimize the risk of electrical hazards and ensure the reliable operation of electrical systems. The risk assessment tools can help determine if an LPS is required, but professional consultation is highly advised. The absence of a required LPS does not guarantee zero risk.